Hello friends, let's start for the demand paging concept from the operating system. Now, as we know, our operating system supports multiprocessing concept, means our operating system can execute multiple processes simultaneously. Now, for the execution of this multiple process, we need to bring this process into the main memory for the execution. Now, let's consider one scenario. Here we'll have the 10 MB of main memory and we'll have the two processes P1 and P2 whose requirement is 5 MB and 7 MB respectively. So now while operating system executing these processes simultaneously, there is a problem for the space in the main memory because the main memory size is 10 MB and our requirement is 12 MB. So now here, while executing this process, operating system done the paging. Now the paging means operating system is going to divide this process into the pages, and these pages are going to be loaded into the secondary memory, that is called the virtual memory. So now, as per the requirements of the process, we are going to load these pages into the main memory. Means for the execution of the process, it is not necessary to load all the pages into the memory. If some part of the process is present in the main memory, then it is possible to execute the process. And now while executing as per the requirement of the process, as per the demand of the process, we are going to load these pages from secondary device to the main memory. That's called the demand paging. Now let's see the concept of demand paging. Now here we'll have the main memory and we'll have the process P1 and its requirement is A, B, C, D, C, A, C, C. It means the process P1 has divided into these pages. Now our operating system has allocated 4 frames in main memory for the P1 and 4 frames for the P2, and P2's requirements are E, F, G, H. Now here, as we know, we'll have the secondary memory which contains the different pages. Now these pages are loaded into the virtual memory and we can call it as a swap device. In this swap device, we have loaded all these pages. So now here, as per the requirements of P1, first of all, we are going to load the page A into the main memory, then B, then C, and then D. So now this process, we can call it as a swapping. So now in this way, we are going to load E, F, G, and H pages from the swap device to the main memory. So now here, the requirement of P2 is E, F, G, H. So now here, the P2 has completed its task. But now here, P1 has loaded into the memory pages are A, B, C, D, and the requirement is C, A, and C, C are still remaining. So now there is not enough space in our main memory. So now here we need to perform the swap out process. So now while swap out process, those pages are free or idle in the main memory, we are going to swap out into the secondary memory. Now here our requirement is CA and CC. So now for this purpose, we need to swap out E and F into the secondary memory. So now, as we know, C and CC is our requirement for the P1 and we have already swapped out E and F into the secondary memory, and now we'll have the 2 more frames free in our main memory. So now here we are going to load, or we can call it as a swap in, the CA and CC into the main memory. So now as per the requirements, it means while execution of this process P1, it means P1 is already in execution. Now while execution, it's going to demand for the CA and CC for the completion of its task. So now this concept, we'll call it as a on-demand swap in. Now here when P1 got all these pages, now it has completed its task. So this concept we can call it as a demand paging. Thank you.